Hey everyone, today we're going to take a look at the 2025 HSC Maths Advanced paper, specifically section 2, and we're going to take a look at questions 23 to 31. Question 23, part A says, in a flock of 12,600 sheep, the ratio of males to females is 1 to 20. The weights of the male sheep are normally distributed with a mean of 76.2 kilos and a standard deviation of 6.8 kilos. In the flock, 15 of the male sheep each weigh more than 8 kilograms. Find the value of x. So we know that this is going to be a normal distribution question, obviously hinted by those two words. And essentially we're finding the value of x. So what I like to do is sort of work backwards. So we know that x is found in this piece of information that says 15 of the male sheep each weigh more than x kilos. So how many male sheep are there? And we can use, I guess, this first line to figure that out. And we know that the ratio is 1 to 20 of males to females, which means 1 out of 21 sheep are males. So what we can say is total males is equal to 1 out of 21 multiplied by 12,600. And what we get is 600 male sheep. Therefore, the probability that the weight is greater than x is equal to 15 out of 600. So once we know this, this sort of just simplifies down to 0.025 or 2.5%. And what we can say is that we know the probability that w is greater than x is equal to 1 minus the probability of w being less than or equal to x. So that means we can sort of reorder this and say the probability that w is less than or equal to x is equal to 1 minus the probability that w is greater than x, which is 1 minus 2.5%, or in other words, 97.5%. And I guess we should be ringing, alarm bells should be ringing and saying, hey, this 97.5% is very familiar when we're dealing with normal distributions. And if we look at the normal distribution, it should correspond to a z-score of 2, where I guess the area under the curve before a z-score of 2 is 97.5% of the curve, 97.5% of the area under that curve. And so then we can use our knowledge of the empirical rule, as well as translating a score such as x into a z-score, and we can say, well, this z-score of 2 is x minus the mean over the standard deviation, and so 2 is equal to x minus the mean, 76.2, over 6.8. We can rearrange and we get x is equal to 76.2 plus 2 times 6.8. I should say these are, I guess, approximately equal to. And then so we get x is approximately equal to 89.8 kilograms. B says the weights of the female sheep are also normally distributed, but have a smaller mean and smaller standard deviation than the weights of the male sheep. Explain whether it could be expected that 300 of the females from the flock each weigh more than x kilos, where x is the value found in part A. So we actually don't really care about whatever the value of x is. What we want to know is if it can be expected that 300 females each weigh more than whatever that value of x may be. In this case, it's 89.8 kilos. So this requires knowledge on, I guess, how the shape of the normal distribution works. And we can say that 300 out of 12,000 is equal to 2.5%, which is obviously the same as what we derived over here, what we found out in part A. And then we can use our knowledge of z-scores and say, well, the z-score is going to be equal to x, that value, minus the mean of females over the standard deviation of females. And if the mean as well as the standard deviation is smaller, then that means the z-score is going to be larger, at least than the z-score of the males. So I should have said the z-score of a female sheep. For any given value of x, that z-score is larger. So that's exactly what I'm going to write. So z-score of a female will be larger with a smaller mean and smaller standard deviation. Therefore, the proportion of females with WF, the weight, greater than X is smaller than 2.5%, which we now know is also 300, and therefore smaller than 300. So I guess in summary, it can't be expected. Therefore, not expected to exceed. Not expected to have 300 females, weighing at least X kilos. Question 24 says the graphs of y equals ELN x and y equals ax squared plus c are shown. The line y equals x is a tangent to both graphs at their point of intersection. Find the values of a and c. So what we should know is that since y equals x is a tangent, then that means gradient is equal to 1. Because I guess, if you were to derive y equals x, you would get a gradient of 1. So if we derive the line y equals e ln x, so y equals e ln x, so that means dy dx is equal to e on x, and we know the gradient is equal to 1, so that means 1 is equal to e on x, so we know that the x-intercept is equal to e, and that means therefore y is equal to e, because it's this point here, and that's along the point y, that's along the line, I should say, that y equals x, and so that means y equals e. So therefore E, and m equals 1. On top of that, we now need to bring in the parabola, and through the parabola we then need to get our values for a and c. So we know that y is equal to ax squared plus c, so that means dy dx is equal to 2ax. X equals e, dy dx is equal to 1, because yet again it's an equation of the tangent, so we know that it follows the same gradient. Therefore 1 is equal to 2a times e, and we can get that a is equal to 1 on 2e. Now that we also know this, we can then say therefore y equals e times 1 on 2e, which is a, times e squared, which is the value for x, plus c. So what I've done there is I've just substituted y equals e, x equals e, and then that value for a that we now know. And we get e equals half e plus c, and then we get c is equal to half e, just by using basic algebra there. And that's our answer. Question 25a says, show that the derivative of sine x minus x cos x is equal to x sine x. So we're going to need to use VUV for this portion of the derivative. Let's call this u, and let's call this v. And then the derivative is going to be v times u dash plus u times v dash. So what we can say is dx of sine x minus x cos x is equal to, so the derivative of sine x is cos x minus this whole VUV thing here, so which is going to be cos x times the derivative of x, which is 1, plus x, which is u, times the derivative of cos x, which is negative sine x. Now if we expand the bracket and simplify everything, what we get is cos x minus cos x plus x sine x. The cos x's cancel, and we're left with x sine x. Part B says, hence find the value of the integral from 0 to 2025 pi of x sine x. So if we integrate 0 to 2025 pi x sine x dx, what we've proved up here is that x sine x is equal to that derivative. And so we can just sort of pop that in. So 0 to 2025 pi d dx of, what was it? Sine x minus x cos x dx. And if we integrate the derivative, essentially what we just end up getting is that function that's inside. So the integral of the derivative of sine x minus x cos x is just sine x, x cos x. So it's sine x minus x cos x, 0 to 2025 pi. And then we, just sub it in. So sine 2025 pi minus 2025 pi times cos 2025 pi. So all of that minus sine 0 minus 0 times cos 0. If you plug all of this in a calculator, what you'll get is, let me just do some equals here. What you'll get is 2025 pi. 25c says the regions bounded by the x-axis and the graph y equals x sine x for x is greater than or equal to 0 are shown. Let an be the integral from n minus 1 pi to n pi x sine x dx, where n is a positive integer. It can be shown that an is equal to 2n minus 1 pi. Find the exact total area of the regions bounded by the curve y equals x sine x, and the x-axis between 0 and 2025 pi. So this is different to the above question. The above question was asking for the integral. And so that integral, takes all of those areas, but anything below the x-axis, like this and this, it subtracts. And anything above, it adds. What we want to do is, just add all of it together. So we want to find the area, and so we would like to take the total sum of that area, and hence that's why we, apply an absolute value. So what we can say is that the area is equal to A1, which would be this section here from 0 to pi, or 0 to 1 pi, plus A2, which would be this section here, 1 pi to 2 pi, plus A3, plus A4, all the way to A 2025. And I guess if we substitute, this should be the absolute value of all these areas, all these values. And if we substitute, I guess, the rule for this, which is 2n minus 1, so we take whatever the number is that's indexed, so A1, so we substitute n equals 1, and that will get us pi, plus 3 pi, plus 5 pi. So if you keep subbing it in, you'll get all the way up to 4049 pi. We can filter out the pi, and what we will realize is that we have an AP. So this is an AP, so an arithmetic progression, with A equals 1, the last number equal 4049. We've got the difference equal to 2, and we've got the number of terms n equal to 2025. And what we should also know is that, I guess if we want to figure out the sum of an AP and we have the first and the last numbers, it's the number of terms, 2025, divided by 2, multiplied by 1, so the first number, 1, plus the last number, 4049. And plug this into a calculator, and we get 4,100,625 pi units squared. Question 26 says, a piece of wire is 100 centimeters long. Some of the wire is to be used to make a circle of radius r centimeters. The remainder of the wire is used to make an equilateral triangle of side length x centimeters. Show that the combined area of the circle and the equilateral triangle is given by the equation as shown. Alright, so we want to find area. Now what we should notice is that this is, I guess, this whole equation is a function of x. So that is the length of the equilateral, the side length of the equilateral triangle. So now that we know this, well, the area of the circle is going to be pi r squared. Now what we need to figure out is whatever that radius is, so that we can, I guess, figure out what the circle, the area of the circle is going to be. Now we know that the remainder of the wire after whatever's used from the circle is then used for the equilateral triangle. So the perimeter of the triangle is equal to 3x, and that means the total perimeter P is equal to the perimeter of the circle plus the perimeter of the triangle. We know the total perimeter, or the total length of y, is 100 plus the perimeter of the circle plus 3x. So that means we can say the perimeter of the circle is equal to 100 minus 3x. We should know the perimeter of the circle is 2 pi r. So that's equal to 100 minus 3x. And that means r is equal to 100 minus 3x over 2 pi. So once we have this, I guess now we can realize that the area of the circle is equal to pi times 100 minus 3x over 2 pi squared. What we should also know is that the area of the triangle by the area rule is half times x times sine 60 degrees, so half AB sine C. And because it's an equilateral triangle, the angle between all three sides is going to be 60 degrees. Sine 60, we should know, is root 3. And so what we get is root 3 over 2 x squared. Sorry, sine 60 is root 3 over 2. And that means we get root 3 over 4 x squared. And so that means if we say the total area is equal to, I guess, the sum of these two areas, which is going to be root 3 over 4x squared plus pi outside of 100 minus 3x on 2 pi all squared. We can simplify this a little bit and try and get it into, the form they want us to, which really just factors out a quarter. So we are going to have a quarter root 3x squared. If we multiply all of this, what we're going to get is a quarter times 100 minus 3x all squared over pi. And then we factor out the quarter, and we get root 3x squared, a quarter outside of root 3x squared, plus 100 minus 3x all squared divided by pi. And obviously that's what they wanted us to show. So that's part A complete. Part B says, by considering the quadratic function in part A, show that the maximum value of AX occurs when all the wire is used for the circle. So what we need to first consider is, okay, so they want us to use the fact that it's a quadratic function. So what are the properties of this quadratic function? And we should, identify that it's concave up. And that's because it's going to be a positive coefficient of x squared. So what we have is the coefficient is positive here, root 3. And if you think about whatever the coefficient of the x squared in this term is going to be, it's going to be positive. And the reason being is because if you were to expand this bracket, you would eventually get to something that has plus 9x squared. And that's obviously positive. So that means we're going to have a positive coefficient of x squared. So I'm going to skip a few steps, and I'm going to say coefficient. So what I would recommend is I would actually expand and collect like terms of the quadratic function. But I'm just going to say the coefficient of the function is 1 over 4 outside of root 3 plus 9 on pi, which is greater than 0, therefore concave up. So what does this even mean if it's concave up? If it's concave up, it means the maximum occurs at an end of the range of the range. So the range of x values that it could take, it's going to occur at one of those maximum points. Now, if you think about what the maximum points could be, or what the ends of the range are, so that could be when x equals 0, or it could be when x is equal to 100 over 3. So if you think about it, what x actually means, x equals 0 means that there is that all the wire is used on the circle, and x equals 100 on 3 means that all the wire is used for the triangle, because we've only got 100 centimeters? Yeah, 100 centimeters of wire to use. Divide it by 3 because each side of the equilateral will have 3 sides. And that's what we have. So what we're simply going to be checking is, I'm going to substitute each of these values into the quadratic function, see what we get, and depending on the value, whichever one's larger is going to be the maximum. So essentially, I'm going to skip a few steps, but I'm going to say the area of when x is equal to 0 is roughly equal to 796, and the area of 100 on 3 when x equals 100 on 3 is roughly equal to 481. This should be centimeters squared, centimeters squared. Therefore, what is it? Maximum value of AX occurs when all while is used for the circle. That's it. Question 27 says the shaded region is bounded by the graph y equals half to the power of x, the coordinate axes, and x equals 2. Use two applications of the trapezoidal rule to estimate the shaded area, the area of the shaded region. So the trapezoidal rule essentially splits the section up into trapezoids or trapeziums. And using two applications means that, I guess, we take two different parts. So these three lines here, and we connect them to make a trapezium, or at least two trapeziums. And the area that we're calculating with the trapezoidal rule is the area of both these trapeziums. So the formula is b minus a over 2n, all outside of f of a, which is first, plus f of b, which is last, plus 2 times f of, I guess, all the x's, or all the x values in between. In this case, it's just going to be one x value, because, you know, if this is a0 and this is b2, then the one in between is just 1. Using two applications, that is. So what we have is b minus a, which is 2 minus 0 over 2 times 2, all outside of f of a, which is f of 0, which is just 1, plus f of b, which is the y value of this coordinate here. So if we substitute x equals 2 there, what we'll get is half squared, or in other words, 1/4, so plus 1/4, times 2 times a half, which is just if we substitute x equals 1 into the equation of the line. Putting this all into the calculator, we get 9 on 8 units squared. Puppy says show that the exact area of the shaded region is 3 on 4 ln 2. So the exact area means we're going to be integrating half x dx. What I'm going to do is I'm actually just going to change this to 2 to the power of minus x dx. Now to integrate this, I'm going to put a minus out the front. And that's because I want the derivative of the function to be in front of this whole line. And that's going to allow me to integrate it like so. So it's equal to 2 to the minus x over ln 2. From 0 to 2. And that's going to be equal to minus outside of 2 to the minus 2 over ln 2 minus 2 to the minus 0 over ln 2, which is equal to minus, what is it? It's going to be 1 on 4 ln 2 minus 1 over ln 2, which is just going to be minus outside of minus 3 on 4 ln 2, and then that's just equal to 3 on 4 ln 2. Using your answers from part A and part B, deduce that E is less than 2 root 2. So what we should realize is that the function is concave up. And what that means is that, let's see, what it means is that the trapeziums that we draw, that dotted line is above the actual line of the graph, which means that we overestimate the area using the trapezoidal rule versus the exact area. So that's what I'm going to essentially write. I'm going to say y equals half to the x is concave up, therefore trapezoidal approximation overestimates the exact area. Okay, so therefore what we can say is, well, this area, which is the exact area, is going to be, what is it going to be? It's going to be less than 9 over 8. So we can say 3 on 4 ln 2 is less than 9 over 8. I can say 1 over ln 2 is going to be less than, what is that? 3 on 2. I can say 2 on 3 is going to be less than ln 2. Now if I raise e to the power, so e to the 2 on 3 is going to be less than 2. And that means e is going to be less than the cubed root of 2, the square root of 2 cubed, which is equal to root 8, which is equal to 2 root 2. And that's our answer. That's exactly what we needed to deduce. Question 28 says a farmer wants to use a straight fence to divide a circular paddock of radius 10 meters into 2 segments. The smallest segment is a quarter of the paddock and is shaded in the diagram. The fence subtends an angle of theta radians at the center of the circle as shown. Show that theta equals sine theta plus pi on 2. So this thing here, this area, is a quarter of the whole circle because it's the whole circle is the paddock. And the question also tells us that r equals 10. We know the radius is equal to 10. So the area of the segment we know is equal to 1/4 times the area of the circle. But we also know that the area of the segment is just equal to the area of the sector minus the area of the triangle. So it's I guess this sector minus the triangle here. So that means we can, I guess, combine these two equations together, and we could say therefore quarter times the area of the circle is equal to the area of the sector minus the area of the triangle. And that means a quarter times pi times 10 squared. So the area of the circle is pi r squared. The area of a circle is half r squared theta. So half times 10 squared theta minus the area of the triangle, which by the sine rule is going to be half times 10 times 10 times sine theta. So what we get is 100 on 4 pi equals 100 on 2 theta minus 100 on 2 sine theta. What we can do, I guess, is divide everything by 100 and multiply everything by 4. And what we will get is pi equals 2 theta minus 2 sine theta. And what we'll get is 2 theta is equal to pi plus 2 sine theta. Divide everything by 2 and we get theta is equal to sine theta plus pi on 2. And yep, that's our answer there. That's what we needed to show. Part B says the graph of y equals sine theta plus pi on 2 is shown. Use the graph and the result in part A to estimate the arc length of the smaller segment to the nearest meter. So the graph is sine theta plus pi on 2, which is this. And what we found out in part A was that this sine theta plus pi on 2 is equal to theta given these conditions. So we know that, theta is equal to sine theta plus pi on 2 given all the conditions. So what we're going to do is we're going to graph, I guess, y equals theta, which is just the same sort of graph as y equals x. So it's going to, I guess, look like that. So it's going to keep going. So we can say this is y equals theta. And their point of intersection, I guess, is where they equal each other. And that is at 2.3. So that means we know that theta is equal to 2.3. That's the solution to the equation. So theta is equal to 2.3. Sorry, let me continue this in black. We know the arc length is equal to r times theta. And so that means it's equal to 10, which is the radius, times 2.3, or at least it's approximately equal to, because I guess that's what we're sort of using with the intersection of the curve. And that's equal to 23 meters. And that's our answer there. Question 29 says the point T is the peak of a mountain and the point O is directly below the mountain's peak. The point Y is due east of O and the angle of elevation of T from Y is 60 degrees. The point F is 4 kilometers southwest of Y. The points O, Y, and F are on ground level. The angle of elevation of T from F is 45 degrees. Part A says let the height of the mountain be h. Show that OY is equal to h on root 3. This should be pretty simple. We see OY, we see h, and we see that they're both part of the same right angle triangle. So we've got, I guess, relative to the 60 degrees, we've got the opposite side and we've got the adjacent side. So that's going to be, I guess, hinting that we're going to be using tan. So tan 60 degrees is equal to opposite, which is h, over adjacent, which is OY. And then we can say OY is equal to h on tan 60. And tan 60 is equal to root 3. So it's equal to h on root 3. And that's what we get there. Part B says, hence or otherwise, find the value of h corrected 2 decimal places. So we're probably going to be needing to do something similar here, where I guess OF is going to provide a similar equation, or we're going to get a similar equation for OF there. So what we can see is that we've got H here, we've got OF, and we've got the 45 degrees. And so we can bound this all together by tan. So tan 45 degrees is equal to h on OF. That means OF is equal to h on tan 45. Tan 45 is just equal to 1, so that means OF is equal to h. And what we can see or say is, so we know OF, we know OY, at least they're in the form of h, h is a function of OF and OY. So to bring this all together, we've got the 4, we've got each of these 3 sides, but how do we actually bring all this information together? Well, we need an angle. And the angle that we're going to get is this angle here. And the reason being is because there's a bit of information that they give us, but they don't show us. And that is this line here. The point F is 4 kilometers southwest of Y. Now, if I draw like a north line here, southwest is there. Now, if it's southwest, what we should know is that it is, what is it going to be? It's going to be 225 degrees. That's what the bearing is. We know if we go all the way, we know because we know Y is due east of O, and that means if we find this here, we're going to get 45 degrees, because if we take the 45 and we add the 225, we get 270, and yeah, that's essentially the bearing due north to get west, which is, I guess, O from Y. So I hope that makes sense there. So we know angle OYF is 45 degrees. And now we have all three sides of a triangle. We have the angle, so we can use the cosine rule to help us, I guess, bring all these into one equation. So using cosine rule, we know that OF squared, so this here, is equal to this line here, is equal to OY squared plus OF squared, or sorry, FY squared, minus 2 times OY times FY times cosine of the angle in between, which is 45 degrees. And if we just substitute our values here, we get H squared is equal to H on root 3 squared plus 4 squared minus 2 times H on root 3 times 4 times cos 45 degrees. So we get H squared is equal to H squared on 3 plus 16 minus, now cos 45, we should know is 1 on root 2. So what we're going to get is, what are we going to get? We're going to get 8H on root 3 times root 2, which is just equal to root 6. And then so we're going to get 2 on 3H squared plus 8 on root 6H minus 16 is equal to 0. And then we can just use the quadratic formula. I'm not going to write this out, but you can as well. So you would write this out in your own working, but using quadratic formula, we're going to get two solutions, but one of them is positive and one of them is negative. So what we're going to get is H is approximately equal to 3.03 or minus 7.93. But H, because it's an actual length, is greater than 0. Therefore, H is equal to 3.03 kilometers. Part C says find the bearing of point O from point F, correct to the nearest degree. So that is going to be this here. So if we say that's north, it's going to be this bearing here, or this angle. And what we're going to do is we're going to use sine rule to find, what are we going to find? We're going to use sine rule to find this angle and subtract it from 45 degrees, and that will get us this. So what we need to realize, I think, is that this whole angle is 45, and that's because we know F to Y, or Y is due northeast of F, because we know from here that F is southwest of Y. So that means Y is northeast of F. So what we can say is, using sine rule, we can say, let's call this theta. So we can say sine theta over OY is equal to sine 45 over OF. So sine theta over OY, or I should say H over root 3, is equal to sine 45 over, what is it? It's over OF, which is just H. And if we substitute our value, what we'll get is, eventually we'll just get sine theta is equal to 1 over root 6. And so we'll get theta is equal to 24 degrees. And that means the bearing is equal to the 45 degrees minus 24 degrees. And that's just equal to 021 degrees, because remember, we want to have this in as a bearing, and so that will require us to have the 3 digits there. Question 30 says the parabola with equation y equals x minus 1, x minus 5 is translated both horizontally to the right and vertically up by k units, where k is positive. The translated parabola passes through the point 611. Find the value of k. So if we have a function, f of x, to translate it to the right by k units means we take the function and we do f of x minus k. And that is if we want to translate it to the right. If we want to translate it vertically, then we add k outside of the whole function. So that means the translated equation is y equals, so it's x minus k minus 1 outside of x minus k, then the minus 5, plus k. Let me fix that up. Plus k. And so we know it passes through the point 611. So at 611, we have 11 equals 6 minus k minus 1 outside of 6 minus k minus 5 plus k. I guess if we just simplify those brackets a little bit more, we have 5 minus k outside of 1 minus k plus k. Expanding those brackets, we get 5 minus 5k minus k plus k squared plus k. And then so we get 11 equals 5 minus 5k plus k squared. And then so we get k squared minus 5k minus 6 is equal to 0. If we want to factor this, we can say it's k minus 6, k plus 1 equals 0. Therefore, k equals 6, k equals minus 1. But we know that k is greater than 0. Therefore, k is equal to 6. And that's our equation. Question 31, the last question of the paper, says the equation cos px equals half has two solutions, where x is between 0 and 2 pi and p is greater than 0. Final possible values of p. So to solve this, we're going to just treat it like a normal trig equation, first of all. So px is equal to cos inverse cos of a half, which is just equal to pi on 3. And that's going to be our reference angle. And using ASTC, we, got a bit ahead of myself there. So we know cos px is greater than 0 as it's equal to positive 1 over 2. And cos is greater than 0 in the first and fourth quadrant using the ASTC rule. Now, I'm just going to focus on the domain real quick. So the domain is going to be translated because what we have is px instead of x. So for x being between 0 and 2 pi, we have px is going to be between 0 and 2 pi p. So that's really, really important. So just now that we go back to this line, so we know cos is greater than 0 in the first and the fourth quadrant. So therefore, our solutions, which is px, is going to be pi on 3. It's going to be 5 pi on 3, which is 2 pi minus pi on 3. It's going to be 7 pi on 3, which is 2 pi plus pi on 3. So these are, I guess, the first and the fourth quadrant going around and around in the same circle, and so on. It's, you know, it's going to keep going. So therefore, if we divide by x now, we get pi on 3p. We get 5 pi on 3p. Sorry, we divide by p, and we get x equals pi on 3p, 5 pi on 3p, 7 pi on 3p. Now, the reason why I've done 3 solutions here is because, well, we know that we're going to have 2 solutions, exactly. So there needs to be some sort of restriction on p that limits us to the 2 solutions for x. Now, the 2 solutions are going to be these 2 solutions. We need to apply a domain restriction so that only, for p, so that only those 2 solutions work. So for those 2 solutions to work, we're going to be bounded by 2 pi. So remember, if we have, I guess, the ASTC plane, and we take an angle theta, we can sort of just do something like this. And that's what we sort of do. So the cos theta, or the cos px in this case, will have 2 solutions from 0 to 360 degrees, or 0 to 2 pi. And if we keep going around past the 360 or the 2 pi, if we keep going past, we'll encounter a third solution once we go back around again. And that sort of is what this 7 pi on 3p is. It's a third solution, and we don't want that. We want to find the possible values of p so that we don't have exactly 1 solution, we have exactly 2 solutions, and we don't have any more than 2 solutions. So what that essentially means is it means that this value here, this 5 pi on 3p, it needs to be less than or equal to 2 pi. So for there to be what is it? More than 1 solution. So more than 1 solution, this 5 pi on 3p will need to be less than or equal to 2 pi. If it was greater than or equal to 2 pi, what would happen? We would have exactly 1 solution, because the x would fall out of the 0 to the 2 pi range, right? This 5 pi on 3p would fall out of this range, and we would only have the 1 solution, pi on 3p. And we don't want that, because we want exactly 2 solutions. So if we just solve this, what we get is that 5 pi on 3 times 2 pi is less than or equal to p. So we just get that p is greater than or equal to 5 on 6. Now that's just the domain restriction, so that there is more than 1 solution, but we want exactly 2. Or in other words, we don't want more than 2. We don't want 3, 4, 5 solutions, we just want 2. And that's where the 7 pi on 3p comes in, because we want this 7 pi on 3p to now be outside of the range 0 to 2 pi. We want it to be outside of this domain. So for there to be no more than 2 solutions, then that's when we apply this restriction, where 7 pi on 3p is strictly greater than 2 pi. It can't be equal to it because that will still fall in the domain. It needs to be strictly greater than the 2 pi. And so that means we have 7 pi on 3 times 2 pi is greater than p. And what we have is that p is less than 7 on 6. So therefore, when we consolidate these two inequalities, we get that, what do we get? We get that p is greater than or equal to 5 on 6, but less than 7 on 6. And that's what we have there.